So we are going to discuss topic 10b, which is halogen reactions. Halogen reactions. So in your book they have given two types of reaction. One is substitution reaction and another one is elimination reaction. So we are going to discuss first substitution reaction. So especially it is called as nucleophilic substitution reaction. As we have discussed in the previous class, what is nucleophile? So we know that what is nucleophile. Just we need to discuss nucleophilic substitution reaction. So nucleophiles are electron-rich species. They are represented by Nu-1. They can be neutral and they can be negative in charge. So when in a reaction, when one nucleophile substituted another nucleophile and forms a new compound, that type of reaction is called as nucleophilic substitution reaction. So here we are going to discuss nucleophilic substitution reaction. So first reaction we are going to discuss is called as hydrolysis. First reaction which is called we are going to discuss is hydrolysis. So when Rx, say for example any compound which is called as Rx reacts with the water H2O, so it forms a compound. When it is warmed, it forms a compound ROH and releases HX. So we are not going to understand what is the mechanism of this reaction. So what happens in this reaction? First, say for example, if I take compound called CH3CH2 Cl and reacts with the water and it warms, it got warm. So it forms a compound called CH3CH2OH and HX. So this is a simple example of this reaction. So here what I will do is first the bond between carbon and chlorine will break down. In the mechanism, first the bond between carbon and chlorine break down. So what will happen if you remember? I told you that there is an electronegativity gap between carbon and chlorine. The bonded electron will move towards chlorine. So as a result, what will happen? What will happen? Here you will get a CH3CH2 positive ion, okay, and Cl negative ion. So this portion is called as carbocation. This portion is called as carbocation. Okay? And your Cl minus has been released. Now this on carbocation, the nucleophile will attack. Here we have nucleophile is water. This water nucleophile will attack on carbocation. So what product you will get? You will get something here. Say for example, on this carbocation CH3CH2 positive charge, a water molecule attacks. So what will happen? So from here, if you see the structure of water, the water has one oxygen atom with two lone pair electrons. So this lone pair electrons will go to the positively charged carbon and donates their lone pair electron to the carbocation, and it will form a compound such as CH3CH2, here O, here H, here H, and one positive charge here. Because why positive charge? Because lone pair electron has been donated to the positively charged carbon. In the next step, this same element, the same compound will CH3CH2O positive and H and H. What will happen? The bond between oxygen and hydrogen will break down. The bond between oxygen and hydrogen break down. The bonded electron will move towards the oxygen and this hydrogen will become positively charged. So this will become CH3CH2OH and it releases H positive ion. So from here we have released H positive ion. From here we have released Cl negative ion. So end of the day, this H positive ion and Cl negative ion react with each other and forms HCl. So this is the overall mechanism of reaction. Okay.